So here's our question. What is the slope of the tangent to the graph of y equals x squared at a equals 1? All right, sometimes we're going to say x equals 1, a just as sometimes we use to mean that we're referring to a specific constant spot on the x-axis. So sometimes we'll say at a equals 1, sometimes we'll say at x equals 1. I'm going to use a for now. And if I forget which one I'm using halfway through, that would be typical for me. All right, so what we do is we're going to do the usual trick, right, of how we progressed in the past from a rate of change involving 2 points to a rate of change involving 1 point. Was that instead of doing the interval from 2 to 1, right, from 1 to 2, we're going to do the interval from 1 to 1 plus delta x. And we're just going to start from there because we sort of have some experience with doing that now. So what we're going to do is we're going to say that the slope of the tangent, all right, m sub tan for slope of the tangent, is equal to the limit as delta x approaches 0 of f of b minus f of a over b minus a. So again, it's the limit as delta x approaches 0 of our typical slope formula or average rate of change formula, where what we're now going to say is that the b is just equal to a plus delta x. So we're going to, essentially our a is 1, and we're going to look at 1 plus delta x. So, 1 plus delta x is going to be over here somewhere, 1 plus delta x. And then the delta x is going to approach 0. That means this point is approaching this value 1. So you're going to be looking at secants that go like that, and then like that, and then like that. And that's sort of your typical picture of what finding the slope of a tangent looks like. All right, so what that means is that we're really looking at the limit as delta x approaches 0 of f of, so b is a plus delta x minus f of a over, now when I do a plus delta x minus a, as you've seen happens every time, the a's are going to cancel out, so the denominator is just going to be delta x. So in fact, I still haven't taken advantage of the fact that I know what the function is. I'm just putting in f. I know what a is 1. I haven't plugged that. So these are sort of very general statements. So, and now here's another fun thing is that mathematicians get tired of writing delta x all the time. So sometimes we'll use h for some reason. I don't know why. So this is, we also write the limit as h approaches 0 of f of a plus h minus f of a over h. And this is sort of a really important kind of formula that we're going to see a lot. So these are very general statements about the instantaneous rate of change, the instantaneous slope. So for our specific function, f of x equals x squared and a equals 1, the slope of our tangent is equal to the limit as h approaches 0 of f of 1 plus h minus f of 1 over h. So since our function is x squared, that's equal to the limit as h approaches 0 of 1 plus h squared minus 1 squared over h. And this is a very typical formulation of what, how we're going to get instantaneous slopes and rates of change. All right. Now, since I've already, well, let's expand the things up here first. So limit as h approaches 0 of 1 plus 2h plus h squared minus 1 squared. It's 1 over h. So that's limit as h approaches 0 of 2h plus h squared over h. All right. Now, what I was going to say is, since we set it up as a limit from the start, in this case, we didn't even bother with an average rate of change. That's what we really want anyway. We're going to start with a limit to begin with. So since I've already started with a limit, I can already reduce the h's out. I'm even going to be lazy enough to not show the factoring step and say this is just equal to the limit as h approaches 0 of 2 plus h. I am going to be nice enough to put that in parentheses. And then I'm going to say, oh, I know that I can evaluate this by substitution because if I plug in h equals 0, nothing is undefined. So this equals 2 plus 0. So now it's no longer a limit because I've evaluated by substitution, and that equals 2. All right, so what this tells us is that the slope of the tangent line is 2 when x equals 1. All right, using the idea, like this idea, you should recognize this from every instantaneous rate of change we've done. And this is a huge part of what we're doing right now. Okay, so we'll do a couple more things with this in our next video.